There we go. So now we're gonna finish with Chebyshev rule. Pretty cool. We have a normal distribution, which we talked about yesterday, and I said I was gonna call it empirical rule. We're gonna dedicate a whole unit later to this graph, to the normal distribution. But for right now, I just wanted to look at the empirical rule. That was yesterday. Now this we call it normal, and our data should look like a parabola up, going down, like a negative parabola that opens up. We call this the normal distribution. However, our distribution, let me do a graph here. I'm going to erase it because I need this space. Our distribution cannot look like a bell shape sometimes. What if our distribution looks like this? Okay, so that doesn't look that normal. So for graphs, for data that are not normal distribution, we use what we call Chebyshev rule. Okay, and then I even give you guys interesting here. It says Chebyshev theorem says at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. So we're going to use that formula, okay? Now, k, I know for normal distribution, we use this thing called standard deviation. Now here for Chebyshev, we use a k, okay? So k squared. Now here, for example, let's take a look at this thing in here. Let me take a look at an example. Survey of local companies found that the mean amount of travel allowance for executives was 25 cents per mile. The standard deviation was 0.2 cents. So the mean is 25 cents per mile, and the standard deviation is 2 cents. Let's use Chebyshev theorem. Find the minimum percentage of the data values that fall between 20 cents and 30 cents. Okay, so let me figure out what my K is. So standard deviation is nice, but let me figure out what my K is. I'm looking for the values that are going to fall in between 20 and 30 cents. So what I'm going to do, let me divide this. I'm going to go 30 or 0.30 minus 0.20 divided by 0.02. You guys see where I got these numbers from, okay? Cool. So 0.30 minus 0.25. My bad, I forgot this right here. 25 because it's the mean. I just picked the high value here. So 0.30 minus 0.25, the high value minus the average. So that's 0.05 divided by 0.02. The 0.02 is my standard deviation, and it gives me a 2.5. Okay, so my K is 2.5. Now, find the minimum percentage of the data values that will fall between 20 cents and 30 cents. I know my K value. Let me use my formula now. My Chebyshev theorem says 1 minus 1 over K squared. So I'm going to go 1 minus 1 over 2.5 squared. I know 2.5 squared is 6.25. So let me do this in slow motion. I have 1 minus 1 over 6.25. Now let me do all this together. I see there's a subtraction and I see there's a division. So I'm going to do the division first. And there's even a multiplication. So let me do this division first. 1 divided by 6.25. Then I'm gonna multiply it. So I have, as a matter of fact, let me just do this right here. 1 minus 0.16. I just did my division. I'm going slow motion. I could have typed this whole thing to begin with. You can type this on your calculator. Your calculator should be able to do this. You can type it in all at once, but there's a chance. There's a chance that you might make a typo. So that's why I'm going slow motion. 1 divided by 6.25 was 0.16. Now 1 minus 0.16 is 0.84. Okay, cool. 0.84 percentage, how do we write that? 0.84 as a percentage. Right, this is a decimal. How do we write 0.84 as a percentage? Yeah, correct. 84%. So that means that at least 84% of our data will fall in between 20 cents and 30 cents. So you guys see how I did my K, right? You guys figure out how I did my K. Because I was asking what numbers in between 20 and 30. And then I gave you guys that the mean was 25. I just subtracted the big number minus the mean divided by my standard deviation. That gives me my K. Now that I have a K, I'm going to use the formula 1 minus 1 over K squared. It gives me a decimal, but I know how to convert decimals to percentage because I just multiply by 100. I know you're previously, the teacher might have said, move the decimal 2 places to the right. Yeah, that basically means multiply by 100. So Chebyshev rules tells me that 84% of my population will be in between 20 cents and 30 cents. Cool, that's not that bad. Now let's look for a range. So I gave you a range on my first example. I said it's going to be between 20 cents and 30 cents. I gave you guys a range, and I gave you guys a standard deviation and a mean. And then I asked you for a percentage. Let me switch things around. The mean price of a houses in a certain neighborhood are $50,000, and the standard deviation is 10,000. So I'm going to give you guys the mean and the standard deviation. But I want to find the price range. So that means in between two values. Find the price range of at least 70% of the houses that we will sell. Okay, so I know the formula, the Chebyshev formula. 1 minus 1 over K squared. That gives me that percentage. And I know that the range I'm looking for is 70%. So I'm going to say this is supposed to get equal 0.70. Because I'm looking at this as a decimal. Okay, so solve for K. Using this, given the percentage, I should be able to solve for K. You guys might be like, well, Mr. Leonzo, how do I do this? Not too bad. Subtract the 1 first. Let me do this in slow motion. So I have, let me subtract the 1. So that gives me negative 1 over K squared is equal to negative 0.3. Let me erase the 2 negatives. I want to deal with positives only. So I have, technically, I'm going to multiply everything by negative 1. Let me write this as a decimal. I could write 3 over 10, but I can also write 0.3 over 1. Now, the reason why I want two fractions equal each other, because I can flip my fractions. K squared over 1, it's equal to 1 over 0.3. Let me rewrite my K squared. It doesn't look that great. So K squared over 1 is equal to 1 divided by 0.3. Okay, so that's not that bad. So that means that K squared is 1 divided by 0.3. So I'm gonna go 1 divided by 0.3. Let me get the square root of that because I'm solving for K, not k squared. So I find out that my k value is about 1.83. Right. So remember, you have to go 1 divided by 0.3 and then get the square root of that. So I find out my k value is about 1.83. Cool. I can easily find my range now. Let's see, what's my mean? The mean is 50,000. What's my standard deviation? It's 10,000. Okay, and then what's my k? This is the information that I need. My mean, my standard deviation, and my k. Okay, so what's the lowest number that I'm gonna find here on my range? My range is basically two numbers, right? So I'm saying the house prices are gonna be in between two values. The mean is 50,000. My standard deviation is 10,000. So I'm gonna say my lowest value is gonna be 50,000 minus 1.83 times 10,000. You guys see I went mean minus k times standard deviation. Don't forget that multiplication comes before subtraction. So this happens to give me 31,700. Okay, I found the low value of my range. Now what's the high value? I'm gonna go 50,000 plus 1.83 times 10,000. And this happens to give me 68,300. So according to the Chebyshev rule, 70% of all the homes sold in this area will have a price range between 31,700 and $68,300. On your homework, I'm even going to ask you to type in two numbers. So notice how I have, let me go in orange in this case. I have this, no, that's not a good one. Let me go green. Green is easy to see. So the house prices, 70% of these houses are going to be selling between 31,700 and 68,300. As always, if you need some help, I'm just an email away.